The last introduction talk today, and this is where everything ends and sums up in vitro. So you have now heard in detail how some of these diets behaved in the fish. Now you will hear more or less the same story in vitro. It's a lot of results being compiled, and we have tried to squeeze it down to a manageable story. It will be presented again by Fulvio Gandolfi, who you heard this morning. I will just open the presentation. There we are. And yeah, basically, in case there are some new tendencies online, I can say that Fulvio is a full professor at the Veterinary Anatomy and History Department of Agricultural and Environmental Sciences of the University of Milan, Italy, and has his expertise within the establishment of in vitro systems for growing gametes, embryos, and organoids. So, and here is the title: How does the Fish AI platform perform to predict?
Thank you very much, Trond. I need a small technical help because I cannot activate the ladder pointer. There's something interfering. Oh, from there. Okay, thank you very much. And this is... Oh, otherwise it doesn't matter. Well, thank you very much, Trond, and thank you very much, all of you here in vivo, and everybody who is in silico attending the conference somewhere else in the world. Thank you for your time. It's very good for you to give us the opportunity to disseminate and share with you our results. As Trond mentioned, this talk will deal with the final conclusion of the project. So will the Fish AI platform provide any useful results when we need to compare different diets or different ingredients? As we heard this morning, in the first part, before the coffee, we developed this working platform. It's based on the two cell lines, one derived from the proximal intestine, one derived from the distal intestine. And the good thing about this two cell line is they are not the same. They are complementary, and they retain some of the properties of the two tracts of the intestine they are derived from. And then we also developed this two-phase culture system, which puts together the positive things of working with a cell line, which is to have a readily available source of cells, which continually grows. But if you keep them in standard culture conditions, these cells will be poorly differentiated, so poorly suitable for performing functional tests. And so we move them into an enriched environment. There are various possibilities of having different enriched environment. We heard some of them this morning. We narrowed down the choice between two of them. Both of them are based on a dual chamber system with an apical chamber which mimics the intestinal lumen, and a lower chamber which mimics the vascular system. In between, there are either a single layer of intestinal epithelial cells, or in a more complex and sophisticated version, we have also added the fibroblast cells, which make their own extracellular matrix, and we put on top of this a layer of epithelial cells, and this mimic quite nicely an intestinal mucosa. And Nicole showed you a lot of lovely pictures. You see here at the right how the real intestine looks like, and this how it looks like with this Alvetex platform. So quite nicely mimics the two things. And this is a more simplified version of the intestinal wall. Working on this prototype, we arrived to the conclusion, especially because, as I mentioned this morning, we want to reach a sort of industrial grade, so something which is robust and useful for potential end users. Beauty comes to a price, and so we opted for the simpler version. It is not so nice. The morphology is not so nice, but is more robust and repeatable, and we thought that this was more suitable for answering the key question. So if the platform is can provide useful information. Starting from this part, as we just heard from Guru, with the support of Spetting, we developed these 5 diets, which differ from the main source of proteins, the fish meal diet, the soy bean diet, the feather diet, and single-cell protein at 10 or 20%. All 5 of them has been underwent through the in vitro digestion, and so we transformed this pellet in a way so that they can be administered to the cells. And then we begin to analyze the system. So we use both cell lines, the 5 diets. We began with 2 IVD concentration. I don't know if you remember, but basically Amir showed us the range of usable concentration. So 6% was the lowest concentration, 50% was the higher concentration, and we prolonged the experiment for 2 weeks, for 14 days. And these are the results. This slide is a little bit crowded, so let me go take you across this, along this slide. So first of all, the upper line is the proximal cell line, and the lower line is the distal cell line. In this slide, we analyze barrier integrity, which is measured in 2 ways. One is transepithelial electrical resistance, which are the results are shown with these red dots. And the other is the permeability to Lucifer yellow. Amir explained all this this morning. And Lucifer yellow is not supposed to go through an intact barrier, cell barrier. So if you have low bars, it means that the barrier is intact. If you have high bars, it means that the barrier is damaged. And the other way around with the epithelial electrical resistance, if they have high value, the barrier is intact. If you have low value, the barrier is disrupted. So what we see, after 3 days on the proximal cell lines, 3 diets had a major damaging effect. These are the soybean diets, the feather high diets, and the single-cell protein at 20%. At 20% of inclusion. And all 3 of these diets had a damaging effect as the highest tested concentration of 50%. In the distal cell line, only the soybean meals and the feather meal had the same effect. Apart from this, we didn't see any damaging effect for the other diets or for the other concentration for 14 days, after which we ended the experiment. So what all this means? So first of all, the 6% IVD concentration does not allow to discriminate among diets. It's too low, the concentration. 50% IVDs is effective, and in fact, it allows to divide the diets into groups, one which damage cells within 3 days, and the other one that don't. And the other one that doesn't, they don't damage the same. Also, the differentiation between proximal cell line and distal cell line, so the difference between the 2 cell lines allowed us to add another level of discrimination in the sense that the proximal cell line is more sensitive, and so it allows to pick up the damaging effect of the single-cell protein 20% diet. Single-cell protein 10% and the feather meals were identical at all concentration, even at the highest. And then, as Guru mentioned, at this level of inclusion, they probably are equivalent and then can be substituted. It can be a good substitute of the fish meal. So we didn't work with this diet anymore. But we wanted to improve the performance of the platform and try to increase the resolution of the platform. So we have 2 diets which are at the same level and a 3rd diet which is damaging. So we reduce the experiment to these 3 diets. We use a more sensitive cell line, so the proximal cell line, and we reduce the concentration. And since the first effects were evident after 3 days, we began our analysis early on, so straight away at 24 hours. And then we repeated 48 hours and after 3 days again. So here are the results. So if we look at the epithelial the electrical resistance, we see that from the very beginning, after 24 hours, we can have a nice ranking. So the single-cell protein 20 has no effect. The feather meal has a significantly lower effect, and the soybean meal has even more marked effect. Using this parameter, if you use the cell coverage, no difference are evident yet. If we wait a further 48 hours with electrical resistance, the differences become even more evident. And they become evident also using the cell coverage parameter. After 72 hours, things become more confused, and so the two more damaging cells, so the differences become quenched with the electrical resistance, and they're still nicely visible across the with the cell coverage. So this means that you can significantly improve the definition of the resolution of the platform, playing around with cell line, EVD concentration, and time of exposure. So this enable us to have a quite fine definition, a fine ranking among the different diets. Then starting from this the last experiment, we wanted to see if if you could add some more definition, of we can add a different use of the platform, if we can learn if this damage were reversible or not. So we took the same experiment. We exposed the cell, as I said, for 48 hours or for 72 hours. Then we remove the IBDs and replace the IBD with a standard medium. And then we went to look at what happens afterwards. So we follow the TER. Electrical resistance is a very convenient parameter, because you can repeat the analysis on the same sample along the time. And we see that after 48 hours of exposure, the soybean meal and the feather meal, they gradually recover until after 18 days, they go back to the same value of the control medium. But it was just enough, a 24-hour extra exposure to these meals in order to cause permanent damages. So whereas and the same data has been confirmed in a different way, apparent permeability to amino acids, so how amino acids are absorbed through the cell lines at the end of the at the end of the experiment, after 18 days, when the TER was reaching the control value, they also reach a functional effect of absorbing amino acid and a full recovery of the cell coverage. Whereas when the exposure was lasting 72 hours, the cell coverage was not recovered, and the amino acids were flowing freely across the barrier. So we can perform recovery test. It doesn't allow to improve our definition of the system, but introduce another use of the platform. So you can test substances that may help recover or prevent damage of the intestinal barrier. So this is our overall using these parameters. So proximal cell line, short exposure. This the ranking we came up with. Fish meal and single cell protein are equivalent and considered to be the best ones. Single cell protein 20 is the intermediate, and feather meal and soy meal have a lower performance. In the meanwhile, the other two partners, EOLR and NMBU, were performing different tests with the same prototype. And for instance, EOLR, as has been mentioned briefly this morning, they created the same diets using protein digestibility. So even without the cells, can we use this first step to grade diets? And indeed they did. And as Amir mentioned, this grading, this ranking was exactly the same as one obtained in vitro. So even without the cells, the platform provide very useful results or meaningful results. They also work on the metabolic activity of the cells. They use different concentration, proximal cell lines and distal cell line, and they also observe that the proximal cell line is more sensitive than the distal cell line. They provide a ranking. In this case, the metabolic activity is equivalently stimulated by the fish meal and the soybean meal. Then they use the same kind of experiments that I described before, but they use a different concentration, a lower concentration, and they performed it for 2 weeks. And in this case, they were able to differentiate and discriminate between fish meal and single-cell protein 10, who has the best performance, whereas the other 3 diets were at the same level. So similar results with a little bit less discriminatory power. And the same results were obtained with looking at the paracellular integrity with luciferial permeability. So putting all this aspect together, their final ranking would see also for them fish meal and single-cell protein 10 equivalent. In this case, the other 3, soy meal, single-cell protein 20, and feather meal with slightly a different order. Then Guru and Trond perform experiment using the cell lines. They concentrated on the distal cell line, and they're using 6% and 25%, so the same concentration that we used for 3 days. And they also saw that 6% is not providing an efficient ranking, whereas a much better ranking was provided by 25% TVDs. The difference is that in this case, the good diets are fish meal and feather meal. And this has been confirmed both with the TER values and with permeability to larger molecules. But they also perform even more sophisticated, much more sophisticated kind of analysis, a transcriptomic analysis, which is still ongoing. All the very detailed analysis, it takes there are a lot of data to be analyzed and carefully dissected. But the first general data are shown here. And here we see 2 important things. First of all is that there is a very big difference between exposing the cell to the diet and without the diet. And so this is a very critical point. Whatever diet you put on the cells, you elicit a very strong response. And so even when you evaluate your model, you have to take into consideration that one thing is leaving the cell alone and they look nice, and the other thing is stimulating them and testing them and using them. So that can make a lot of differences. And the other thing is that we can see that we have different clusters. The 2 extreme clusters are fish meal and soybean meal, and the other 3 are closer together, more or less as we have seen in the other, using the other parameters. And this is their final ranking. Fish meal and feather meals have a low effect on the distal cell lines. Single-cell proteins, 10 and 20% intermediate, and the lowest one was the soy meal. So here we are. So we analyze the 5 diets with the same prototype in 3 different ways using different parameters, which is a little bit similar to what we did with in vivo. So you analyze 5 diets with different parameters. How do you compare all this? So I try to simplify a little bit the table in order to try to make sense of all of it. And so the first thing we did was to combine all the results of the in vivo trial. And this is the combined ranking with fish meal and single cell protein, giving the overall better performance and the other going down. But we also concentrated on the in vivo health because in vivo health has been derived from the analysis of the distal intestine only. So that could be closely resemble our test on the distal cell line. So we put all this together, then we have the in vivo combined ranking is quite similar to the ranking using the proximal cell line with lower concentration, except with a switch between feather meal and single cell proteins. But the two better diets and the soybean meal are agreed on the bottom. Then if you use the in vivo health, which as we heard from Guru, derives from the analysis, mostly from the analysis of the distal intestine, and we compare with the results obtained in MBU analyzing the distal cell line, this superimposition is exactly the same. So depending on the, once again, if you use the proximal cell line and the distal cell line, you have different results, which is good, and they are meaningful one way or the other way. And then the EOLR analysis was combining both the pre-cell analysis and post-cell analysis, and they confirm the two first the best the equivalency between the fish meal and the single cell protein at 10% level, and the other was a little bit different, especially the soy meal and the feather meal were switched. So where are we now? Situation is complex. Let's look at the bright side of things. The first thing is that we can provide a high resolution ranking of different diets. These results are repeatable within the same laboratory, and that was very important for us. But it's difficult to compare a moving target with another moving target. So we have a different perspective from the in vivo ranking and different perspective for the in vitro rankings. In this respect, we are very similar. But at the same time, if you, depending on what you look at, you have a nice correlation of results. Really, the key question, at least to my mind, is that we are comparing, as we obviously know, a fish with a dish, and the kind of hard data you can take out from a dish and take out from a fish are quite very heterogeneous between the two of them. However, the key to have a positive results in this kind of test is learn how to interpret the two sets of the results. So there are two different sets of results, and interpretation can help you to have a better prediction of what is going on in vivo, or at least supporting the in vivo nutritional trial. In order to improve this kind of interpretation, we definitely need to perform more of these comparative trials. As we heard from Ramon in the morning, all these kind of tests require a background, a database of information in order to be able to interpret them correctly. And the better is the database, and the better is the correction. We are not still at the few minutes time limits that Ramon asked this morning, but we can go down to 24 hours, which is not too bad. And so that's where we are now, and we hopefully we can improve in the near future. And of course, finally, I would like to thanks all the thanks the European Commission that gave us all the money, and we hope we have they will things that we spend them wisely, and all the partners that you have seen this morning. There were a few other people that are not here with us today, Anna Zavo and Rolando Pasquariello, who have been playing an important role in the project, but they moved on to other projects. And then we have this happy time in Mexico with, and then we have Liat Koch and Federica Camin. That Federica has got her PhD out of this project, and now she moved to another lab. And we have our senior advisor, Osil Korsdal, who is here with us today, and Amos Standler, who is, I think, online. And they have given us a lot of wise and very important advices. And thank you all for being here today. Thank you.
Thank you, Fulvio. Excellent sum up of a lot of work during the last 5 years, I think, personally. There is no time for lunch, but I suggest that we stay for a few more minutes to have specific questions to Fulvio, if there are any. And there are, of course, also everything you summarized now serve as a basis for the panel discussion that we are having after lunch. But please, any quick questions before we go to lunch? There is a question over there.
I'm thinking here, when I see the ranking of all these diets, in fact, the one that mixed up the results was the feather meal. That changed a little bit, because the others, fish meal is the best no matter what kind of approach you do. The soybean meal with high inclusion is the worst. And feather meat, depending on when you evaluate, it changes. Do you have any clue why?
Yeah, I think, well, going sort of from inside, the main discrepancy is that the proximal cell line is quite sensitive to feather meal. That was the main differences. Whereas the distal cell line was not, and that sort of raised up the evaluation. As Amir mentioned this morning, we are using these cells in a little bit out of context, so we have no mucus layer protecting them. So the fact that the proximal cell line are more sensitive, it might be due maybe to this aspect that they, without a mucus layer, since they are more specialized in absorption, they get more affected by some kind of ingredients than others. And this goes down to the fact that we need to have a better number of observation, a larger number of observation in order to understand what we see. I don't have time to do it now, but we can go in detail. So we also see inflammatory response, what we consider inflammatory response from the cells in the form of proliferative activities of these cells instead of breaking down the barrier. So sometimes you see the electrical resistance going up instead of down. And we interpret that as intermediate response. So it's not so as toxic as having a very sort of a destroyed intestine or a leaky gut, but it's more like the intestine they try to make up for some deficiency. And again, we didn't have time to show the results in vivo, but Nicole showed that in extreme, in challenging diet, the proximal intestine proliferated also. You actually have a much longer intestine when it's exposed to a very challenging diet, because the folds proliferating and branch out. So of course, as I said, there are two very different set of results. The trick is try to interpret one for the other, and for doing that, you need to have side-by-side comparison. So exactly with any other in vitro techniques. So if you look at the in vitro only, you don't really know what it means. But if you keep on looking in vitro and in vivo, and litro in vivo as the in vitro digestion things, which has been developed for other species and for fish as well, they always understand what is going on when you can do side-by-side comparison. We just started with this side-by-side comparison, and the thing seems to be promising, at least to me, maybe because we work so hard with it. But in general, I think I'm objectively optimistic to the fact that if we add more data, we can understand better what the in vitro trial are telling us. So at the end of the day, is an interpretation of the data that we see and looking at the small differences that will be important.
Maybe one more question that we may answer or can keep in mind for the discussion after lunch, but I would like to bring it up here. It's from one of the online attendees that asks about, I mean, it has briefly been touched upon by Amir and others, the limitations with regards to the animal system, and particularly how do, I mean, other type of interactions with other organs, except what has been mentioned with lack of mucus, lack of microbiota. For example, how does the model take into account energy expenditure to digest the feed and heat increment, for example, that was mentioned earlier?
It's a very good question. The thing is, as I said, we just started, we set up the prototype, and one of the things that we hadn't time to discuss at all is the number of other tests that we are developing. So we are showing here many of them, but many more are being developing. So how things are absorbed, and we can surely begin to measure energy taken and things like that. So now that we know how to use it, now we can amplify the kind of tests that we are are able to do with the cells. And once we are happy that the system is stable, then we are actually doing that.
And we need another project.
We need another project. Yes, EU monitors, please give a good word for us.